Guys, the next is the balancing disproportionation reaction. You know what is disproportionation reaction? And let's check how it can be balanced. Okay, so simply my first example is the disproportionation of manganate, MnO4 minus, which disproportionated to permanganate, MnO4 minus plus MnO2 plus MnO2. Okay, ready. So first check the oxidation state. Here plus 6, here plus 7, here plus 4. Okay, listen. And there is one change compared to the normal balancing. There is a change is, first you find the oxidation state, then you identify which one undergoes reduction, which one undergoes oxidation. So plus 6 to plus 7. So what process? Oxidation. Plus 6 to plus 7. So from here to here, oxidation. And the very same here to here, it is reduction. Plus 6 to plus 4, that is reduction. Okay. So this is disproportionation. So there will be a species with a common oxidation state and it's splitted into the different oxidation state, right? Yeah. Now you simply stand here, which means the side where the different OS is present. The side where the different OS is present. So this is a side where the different types of OS is present for the same element. Okay. Then you find the change. So first of all, you identify the oxidation states. Then you realize that which one undergoes oxidation and which one undergoes reduction. Since it is disproportionation or comproportionation, there will be a side where two different OS exist, right? And you know. And stand that side. Then, no need of balancing the numbers initially. No need of balancing the numbers of manganese initially. You simply balance the electron lost and gained. Then you balanced what? The numbers. Ready? So identify the oxidation state and check where it reduction undergoes and oxidation undergoes, and stand where the different OS is existing. So simply I'm standing here. Then you find the electron lost or gained. So electron gained, this is lost one, oxidation. Electron lost is 1 into 1 manganese 1. Electron gained is 4, 6 to 4, 2 into 1, that is 2. So here electron gained and electron lost are not same. Okay, so you simply multiply here with the 2. Ready? Let it be plus 4. Okay, plus 4. Multiply here with the 2. So only here. Ready? So multiply here with the 2. No need of doing nothing for the side where a single oxidation or a common oxidation state existing. Right? You are not able to do anything here. And the whole process is here. So simply find the oxidation state and check which undergoes reduction and oxidation. Ready? And find how much electron lost, gained. Then make it balanced in that side itself. So here 2 electron gained, 2 electron lost. So by multiplying 2, by multiplying 2 here, only you are permitted to multiply here, not here. Ready? Then if electron lost and gained is balanced, then you can finally balance the total number of atoms in both sides. Here 2 manganese, 1 manganese, 3 manganese. Okay, so you can multiply 3 here. Ready? Now check the OS. Charge. 2 into 3 into minus 2, minus 6. 2 into minus 1, minus 2, plus 4. Minus 2, plus 4. So it will be plus 2. It will be plus 2. Ready? And based on medium, what about the medium? Medium is basic. Let the medium is basic. So you multiply 8 OH minus, you add 8 OH minus here. So there will be 8 OH minus. And balance hydrogen also, 4H2O. So what about the oxygen? 12, 4, 16, 8, 8, 16. So now the reaction is balanced. Okay. We can do more and more examples. Simply the steps are, first, find OS of all. Ready? Find oxidation and reduction part. Okay. Stand the side where different OS existing. Then balance the electron lost and gained. So we still standing in the side where different OS is existing. From the you balance the electron lost and gained. Okay. Finally balance. If this is okay, this is multiplied balanced by multiplying with a suitable number. Finally balance total atoms. Ready? Then rest is same. Balance charge and hydrogen. So here change in oxidation state is considered. Then simply I am standing the side where two different OS existing. Then the electron lost and gained is calculated. Then balance it in that same side itself. Finally, here are 3 because finally the total number of manganese you have to balance. Then you find the charge like that. Okay. So I'm moving to the next case. Listen. The next case or the next example. That is the balancing of P4, white phosphorus, which disproportionated in alkali to form phosphine and H2PO2 minus. H2PO2 minus. Ready? H2PO2 minus. Okay. So from 0 to minus 3. Phosphorus from 0 to minus 3. And here plus 1. Here plus 1. Ready? Okay. So the oxidation states are okay. OS of all elements. All elements, no need of finding all elements. This is disproportionation. So a typical element undergoes oxidation and reduction. So simply I am standing here. The side where the different OS is existing. Okay, fine. Balance the electron lost and gained. So from here 0. So here the reduction part, here the oxidation part. So simply check that from 0 to minus 3. So electron lost is 3. Okay. And from 0 to plus 1. So electron gained is, sorry, here the electron gained is 3. Here electron lost is 1. Okay. So you multiply with a suitable number, 3. 3 here. Here only. Then balance the electron gained and lost by standing here in the different OS side. Finally balance total atoms. So 1 phosphorus. By balancing the electron lost and gained, you obtain 3 phosphorus here, 1 phosphorus here. So this side have 4 phosphorus. Already in this side it is 4. So it is, this step is okay. Then charge. 0, -1, having a -1 charge. What about this one? Force P in the charge is 0. H2PO2 minus having the charges -1. So here 3 into -1, -3. Now our medium is basic, so we can add 2 OH minus here. So simply I am adding 2 OH minus here, and these 2 OH minus along with the combination with the given OH minus, it becomes 3 OH minus. Now the charge is balanced. You finally balance the hydrogen. Here we have 3 hydrogen, 6 hydrogen. So 6 hydrogen is excess in the right side, so you have to supply 3 water here. Now the reaction is balanced. Simply check the number of oxygen. 3 oxygen, 3 oxygen, 6 oxygen. Here also 6 oxygen. So the reaction is balanced. Okay. Moving to the next category. Moving to the next example. Let I have the disproportionation of chlorine in presence of cold dilute alkali to chloride and hypochlorite ion. And this is in the presence of basic medium. Okay. So let me show the skeleton reaction once again and balance it in the same fashion. Find the oxidation state. You know that the chlorine is the element which undergoes disproportionation. So you simply find the oxidation state of chlorine itself. So here the chlorine -1, there the chlorine +1. And here the chlorine is 0. Fine. So you simply stand here where the different OH is existing. Find the number of electron lost or gained. Here gaining, the losing. Here lost, gained is from 0 to -1, 1. Lost is from 0 to +1. That's also 1. So gained and lost are same. Ready. Gained is 1, lost is 1. So it is okay, perfect. Then you simply balance the electron gained and electron lost is already balanced. You simply balance the total number of atoms in the both sides. 1 chlorine, 2 chlorine here, and this side also 2 chlorine. So it is balanced. Okay. Then what? Finally balance the total number of atoms. Before that charge 0, -1. The charge is -1 here. And here are -1 all of charge, -1 all of charge, right? So both have -1, -1, -2 charge. So our OH minus is required here. So that OH minus with this OH minus, it will be 2 OH minus. And so that there is 2 hydrogen increase. So you give H2O here. So the number of oxygen, 2 oxygen, 1 + 1, 2 oxygen. So the reaction is balanced. Okay. Ready? Moving to the next case. That is, the next case is listen carefully. Let me balance a comproportionation reaction. That is I minus plus IO3 minus become I2. In acidic medium. This with the skeleton. So this is a comproportionation, right? That means a reverse of disproportionation. Okay, let me balance that. So simply find the oxidation state -1. Here the oxidation state +5 of iodine. Here 0. Fine. And find oxidation and reduction part and stand the side where different OH is existing. So here the different OH existing is left side because this is comproportionation. So simply I'm standing here. Okay. Then balance the electron lost and gained. So -1 to 0, it is losing. So electron lost is 1. +5 to 0, gaining. So electron gained is 5. So balance it by suitable number. So here 5. So that step is okay. Then you balance the total number of atoms. 5, 1. 5, 1. Total 6 iodine is there. So you have to supply 3 here. And only the right side and left side will be 6 iodine. Then the charge. 5 into -1, -5. 1 into -1, -1. That is -6 here. And here the charge is 0. Now the medium is acidic. So 6H plus is here. And if 6H plus is here, there will be 6 hydrogen. So you multiply 3H2O here. What about the total oxygen? 3 oxygen, 3 oxygen. It is balanced. And this is how disproportionation and comproportionation reactions are balanced. More idea that you have to know, that is balancing half reaction. Balancing half reaction. The method is known as half reaction method. The method is known as half reaction method or ion electron method. Half reaction method or ion electron method. Okay. Listen here. Let I have a half reaction MnO4 minus which become Mn2 plus. MnO4 minus that have to become Mn2 plus. And the reaction which is in acidic medium. Ready? Let me balance this one. It is very easy. MnO4 minus which turns to Mn2 plus in acidic medium. First you find the change in now oxidation state. 7 here, 2 here. And check their numbers are same. Yeah, their numbers is 1 here, 1 here. Fine. Then find the electron gained. Since this is a reduction half, electron gained is 5 into 1, 5. So the total number of electron gained is 5, right? Electron gained means before the reaction you have to show the electron, right? What about the case of reduction half? In the case of reduction half, well, let us have an example. Cu2 plus plus 2 electron gives Cu. Okay. In the case of reduction, electrons are represented before the arrow, before the reaction. What about oxidation half? In the case of oxidation half, usually electrons are projected after the reaction. That is the only idea that you have to memorize. Okay, so here 5 electrons is gained. Then you show the gained electron before the reaction. Is it okay? Gained electron before the reaction. So then you find charge. Then you find the charge. Charge -1 from permanganate and 5 electron having 5 negative charge. So -6 in the left side. And in the right side there will be a +2. So the charge is not okay. Then consider the medium, acidic medium. So supply 8H plus here. Then only both sides become +2. So that 8H plus 2 here increases 8 hydrogen here. So you add 4H2 on the right side. So find the oxygen, 4 oxygen, 4 oxygen. The oxygen is balanced. Now the reaction is balanced. Okay. So the steps are find OS, okay. OS is simply you have to find OS, then make the numbers same for element with the change in OS. So if you are able to find the oxidation state, and then you know that which element undergoes oxidation or reduction. Here only either oxidation or reduction, because the given half may be oxidized half or reduced half. Ready? Okay. Then once you find the elements with the change in oxidation state, you make their numbers same on the both sides. Okay, then find electron lost. If it is oxidation half, then you obtain electron lost. Or if it is a reduced half, you obtain electron gained. You simply find that electron lost or gained. Ready? Then once you obtain the lost electron and gained electron data, then you represent that electron in the proper side. If it is reduced stuff in the before arrow, before the reaction, or if it is the oxidized stuff after the arrow, like that. Okay. Show electron on proper side. Ready? Then balance the charge. You know how to balance the charge based on medium. Finally, hydrogen also. So that is the steps. Okay, I'll give you some more examples for balancing this category. Listen carefully. Let I have half, that is reduction of permanganate in basic medium. Reduction of permanganate in basic medium. So let me show it once again. MnO4 minus, which gives Mn4 plus. MnO4 minus, which gives Mn4 plus. Listen, here the manganese is in +7 and here it is in +4, right? Okay. So change in OS is calculated. Make the number same. One manganese. That is also okay. Find the electron lost or gained. Here the gained, 3 electron gained. 3 into 1, 3 electron gained. So represents that gained electron on the proper side. The proper side is left side because this is a reduction. Then you find the charge. -1 from here and -3 from here. So -4 on the left side. And the right side +4. Then check the medium and balance the charge. So here you have to supply, here you have to supply 8 OH minus. Then only the both side become -4. So 8 OH minus. Then here it will be 4H2. Now 4 oxygen here, 4 oxygen here, there are 8 oxygen. The reaction is balanced. The half is balanced. Okay. Moving to more and more examples. Listen. We have the reduction half of dichromate. That we have the reduction half of dichromate. Cr2O7 2 minus, which is in acidic medium turns to Cr3 plus. Okay. Let me write the half again. Cr2O7 2 minus become Cr3 plus. Find the oxidation state. There are already +3. Here, you know, it will be +6. Okay. So once you find the oxidation state, make the numbers same. Here 2 chromium, then it will be 2 here. Then find electron gained or lost. 6 to 3. So per atom, electron gained is 3 into number of atom 2. So 6 electron gained. And you show it in the left side because this is oxidation half. So 6 electron here. So electron is okay, represented. Find charge. -2 from here and -6 from here, -8. Though we have +6, 2 into 3. And the medium, you know, acidic medium. So supply 14H plus here. So 14H plus here. Then for balancing hydrogen, 7H2 will be there. Now oxygen is also balanced. The reaction is balanced. Okay. So very easy idea. Let's check to oxidation of also. Okay. Then we can wind up this half reaction method. Okay. So I told you that no need of writing the two reactions, oxidation half and reduction half, in two different section and then adding to obtain a full reaction. In order to balance a full reaction, you simply choose the oxidation number method. It is enough. Okay. No need of splitting it into two half and merging finally to get a full reaction like your NCERT said. Okay. For balancing and for the case of questions in an objective type, you are asked to find or you are asked to calculate the or you are asked to solve the full reaction. So you simply choose oxidation number method, or you may ask to find, or you may given with a half reaction and you may ask to find, or you may ask to solve the half reaction. So then you choose half reaction method. Oxidation number method will not be working there. Okay. Let me give two oxidation half. Now oxidation half of oxalate to carbon dioxide. Okay. In the oxalate, we know the oxidation state of, let me show it once again. And this is, in the acidic medium, it becomes CO2. Okay. And carbon here plus 4, plus 3, here plus 4. So this is an oxidation half. So you multiply 2 here. Why? Here we have 2 carbon, then 2 carbon. Then find the electron lost. Lost is plus 3 to plus 4, 1 electron lost, but there are 2 atoms like that. So the lost electron is 2, right? Then you show it in the proper side. And for oxidation half, the proper side is right side. Then check the charge, minus 2. Here from carbon dioxide, 0, from the minus 2. So both sides have minus 2 charge. So no need of adding H plus or OH minus here, which means that the reaction is balanced. Okay, because there is no hydrogen excess. So 4 oxygen. Now the half is balanced. Okay. Moving to next example. That is the oxidation half of iodide in basic medium to IO3 minus. In strong basic medium, iodide oxidized to iodate. So the oxidation states are minus 1 here and plus 5 here. What about the number? Numbers are same. Ready? Then you check the electron lost. Electron lost is from minus 1 to plus 5. The change in oxidation state is plus 6. 6 into number 6. So 6 electron lost. So that 6 electron you have to show here. Ready? Then the charge, minus 1, minus 7. Minus 1 from here and minus 6 from here. Since the basic medium, you supply 6 OH minus here. So 1 6 OH minus here, there we need 3 H2. So hydrogen is also balanced. So 6 oxygen, 3 oxygen, 3 oxygen, 6 oxygen, the both sides. The half is balanced. Okay. One more example. In the oxidation half of sulfite. Sulfite, which is oxidized in presence of H plus 2. Sulfate. Okay. So here the oxidation state of sulfur is plus 4. Here it is plus 6. Ready? Their numbers are same in the both sides. Find electron lost. That is 2 into 1. 2. Because change in OH is 2 and number of sulfur is 2. So you represent that 2 electron here, right? Yeah. Then you find the charge minus 2, minus 2, minus 2, minus 4. So 2 negative charge is excess there. And your medium is acidic. So you supply 2H plus here. 2H plus. So 2 hydrogen will be increased here. So you give an H2O here. So hydrogen is also balanced. What about oxygen? 3 oxygen plus 1 oxygen, 4 oxygen. Here also 4 oxygen. So the reaction is balanced. Okay. So this is how full reaction balanced using oxidation number method, and a full reaction of comproportionation of disproportionation balanced using oxidation number method, and half reactions using half reaction method. Okay. Already told you that there is no need of balancing a full reaction using half reaction method. You simply know how to balance a half reaction, a reduction or oxidation half reaction in half reaction method. Okay. Now we have one more topic. The topic is titration, volumetric analysis.